One of the things we worked on last class is we saw that when we have a rational equation, what makes this a rational equation is we have rational terms in there, so terms that are fractions. And then the equation part, we have that equal sign. So we're solving for values of x. And one thing that we talked about is this is where we can cross multiply. If we have one fraction equal to another, we can cross multiply to solve. But one of the issues we ran into is that sometimes when we cross multiply, there's a lot of simplifying that ends up happening in the end, right? So we kind of got stuck here when we cross multiplied because we got this cubic function that couldn't be factored. And thus the way that we are going to find those solutions was going through the rational root theorem, which again, that's fine, right? We've done that. We have covered that somewhat recently. So it's not that we made any mistakes. It's just that we are looking for an easier way to solve these equations. So what we had worked on is instead of cross multiplying, just finding a way to get rid of all the fraction parts, okay, or all the denominator parts. And that's going to be the approach that we're going to work to take basically from here on out, because I just think it's a lot easier and we don't have to deal with any of the fraction terms there, okay? So I mentioned that there were these steps here and I kind of skipped over them last time. This is essentially what we're doing as we go through all the problems today, okay, where we're going to work to get rid of those expressions. So let's do that right now. And with every rational expression or equation, a really good place to start is factor everything. Okay, that's almost always whether we're adding fractions, subtracting, multiplying, dividing, solving equations, factoring is a good place to start. Okay, so the 1, x minus 2, there's nothing I can do there. I might put parentheses around everything just as a signal to my brain that that part has been factored. Nothing more I can do there. X squared plus 2x minus 15. I'm thinking about numbers that add to 2 and multiply to negative 15. That would be positive 5 and negative 3. The denominator, x squared minus 7x plus 10, factors the x minus 5 and x minus 2. And then the x and x minus 5, nothing factors. Okay, so what we're going to look to do now is multiply this entire equation so that we can get rid of all the denominators. And so how that's going to work is we just want to identify the unique factors in the denominator. We don't want to multiply by every single factor. And what I mean by that is the unique factors are that we have an x minus 2 and x minus 5. That is the minimum that we need to multiply by to get rid of these denominators. If instead you decide I'm going to multiply by x minus 2, x minus 5, and another x minus 2 and x minus 5, you're going to create a really complicated equation that probably brings in the rational root theorem again. Okay, but if we just take that minimum factors and just multiply by the unique factors, the solving portion should go pretty smooth from here. Okay, so x minus 2, x minus 5, I'm going to multiply to every single term in our equation. Okay, and again, once we do this, it looks a little more complicated. I'm not going to write this 1 again, because 1 times x minus 2, x minus 5 is just x minus 2, x minus 5. X plus 5, x minus 3, x minus 2, x minus 5. A lot of terms there. X minus 5, x minus 2, and then plus x, x minus 2, x minus 5. Okay, so again, right, that first step, it looks more complicated. And some of you that are maybe a little more visual may not need to write this out. You can think about what's going to cancel. As we're learning this, I think it's worth you writing this out because it's easy to make mistakes if you're trying to take a shortcut and just thinking about what would cancel out when I distribute those. Okay, so writing it out, I think, is your best way to limit opportunities to make mistakes. But some of you will pick up on what's going to cancel when we multiply those terms out and may not need to write out this entire step. Okay, but x minus 5, x minus 2's cancel, x minus 5's cancel. And so now we don't have any more rational expressions. Okay, all the denominators are gone. And so we're left with x minus 5 on the left side, x plus 5 times x minus 3 on the right side, and then plus x times x minus 2. And now we have a lot of simplifying to do on this right side, and it's looking like we're going to have to solve some sort of quadratic to come up with these solutions. So the x minus 5 on the left side, nothing I can do to simplify that. The x plus 5, x minus 3, I can FOIL and get x squared minus 3x plus 5x minus 15. And then plus x squared minus 2x after distributing this x. Before I start moving terms, I'm going to continue to simplify this right side by combining like terms. So x squared and another x squared is 2x squared. Negative 3x and 5x is 2x. But then I have minus 2x, so all these x's actually cancel themselves out. And so then we just have minus 15. And again, all those x's canceled out because I got a minus 3 plus 5 is positive 2. 2 minus 2, those all cancel. All right, then this is a quadratic equation. And really, maybe we start classifying it as a polynomial because all polynomials, we need one side to be 0. Okay, so whether that polynomial is quadratic or cubic or to the power of 4, we need to get one side to be 0 in order to solve this. So I'm going to subtract x and add 5 to get the left side to be 0, making this 2x squared minus x, and then that would be minus 10 after adding 5 to the negative 15. And now we're just left with solving a quadratic. Ideally, this quadratic would factor. If it doesn't factor, we would go to the quadratic formula. I actually think we're going to be able to factor this one because there's two numbers that add to negative 1 and multiply to negative 20. Those numbers are negative 5 and positive 4. So this is nice. I can avoid quad formula. And again, I'm going to factor by grouping. So this is 0 equals 2x squared plus 4x minus 5x minus 10. And I'm going to group the first two terms and second two terms. So 0 equals 2x, x plus 2. And then minus 5, get that other x plus 2 to show up. And so then this factors to 2x minus 5 times x plus 2. Now that we factored to come up with our solutions, we just take each one of these factored terms and set them equal to 0. So 2x minus 5 equals 0, x plus 2 equals 0. And I get that x equals negative 2, 2x equals 5, so x equals 5 halves. So our solutions are x equals 5 halves and x equals negative 2. And remember, we have to consider the domain restrictions. If any of those restrictions end up being our solutions, we consider that solution to be extraneous. So in the original equation, numbers that would cause us to divide by 0 are x being 2, okay, from that factor of x minus 2. So that's a restriction that x cannot equal positive 2. So far those solutions are good. And then 5 is the other number we need to exclude. So x cannot equal 2 and 5. So in this case, these are both of the solutions, 5 halves and negative 2. Neither of them are extraneous because neither of them cause us to divide by 0. Okay. Any questions with any of the work that I did here? Because there's a lot going on. Okay, I'm not going to sit up here and say that these problems are easy because there's so much that we're doing and so much that we've worked on this entire year to be able to solve this equation. Okay, so let's have you all work through number 7. And again, all that I ask is that you do your very best. Okay, if you work through it and you're not even close to the work that I do, that's okay. Okay, I don't want you to cross that out. Maybe just have an extra sheet of paper ready in case the work you do is kind of far off from what you need to do. But right now, just do your very best with number 7 and see what you come up with. Okay, I'm going to work it out as well. And then we may or may not do number 8. I haven't decided yet. We're going to see how 7 turns out. Okay, give it a few minutes to work through that. Okay, the first step is me just factoring everything. And then I'm identifying all those unique factors. So anything that is in the denominator, and I only want to multiply it the one time. Okay, if it shows up more than once, I don't want to multiply it more than once. Okay, so in the denominator, I see a 3. I need to distribute that 3 so I get that 3 to cancel. Consider different factors. Then the only other thing that I've done is I distributed all those terms. And I stopped because as I was canceling them out, I'm like, I know it can be kind of hard to see what I wrote. So now the only thing that I'm left to do is to cancel out those common terms. And I actually think we get a non-quadratic equation to solve once we're done here. Okay, so it ends up working out pretty nice. So in this first fraction, everything cancels out and we're just left with a 2. In the second expression, I get a 3 and x plus 6 to cancel out, and an x plus 6 to cancel out. So a lot of things go away here, and we end up getting that 2 equals 5 times x minus 3 plus 3. I can then distribute the 5 to get 2 equals 5x minus 15 plus 3, or 2 equals 5x minus 12. And then I can add 12 to the other side, so 5x equals 14. And divide by 5 and get 14/5. So x equals 14/5. Only thing left to do is just check that solution with any restrictions we need to come up with. And the restrictions are that x cannot equal 0 and x cannot equal -6. Okay. Questions there? Kind of nice that we didn't have to do anything with a quadratic. All right, I do want to do this last one, and we'll just do it all together real quick. That way we can get you at least 15 minutes in here to work on some homework, hopefully a little bit longer. And the reason I want to go over it is this +1, sometimes that'll throw some students off. It doesn't change our approach here. Okay, with that +1, we're still going to start by just factoring everything. Okay, so 3x minus 15, I can factor out a 3, and I get x minus 5. And I have x plus 1. Ooh. Now, there's something that we can make this last equation really easy. What did we notice about this expression right here? Lucas, what? It's just 1. All those things cancel out. We could simplify that right away. And you could say that 3x minus 15 divided by x plus 1 equals 1 plus 1. 1 plus 1 is 2. That'd be really easy to solve from there. You would cross multiply. Oh, you could be done with that equation in 1 minute. I'm going to pretend that we don't see that, though, because that's typically what's going to happen. That's a hard thing for us to recognize, right? There's so much going on here. If you see it, roll with it. Okay, call that 1, do 1 plus 1 is 2, and solve from there. I'm going to approach it as if I don't recognize that. And so I continue to solve the same way by factoring. So x minus 3 minus 2. X minus 3, x minus 2. And then the 1 I can't factor at all, so I'm going to leave that as is. Ooh. No, thanks for pointing that out. What were you going to tell me, Grace? It's not the same. I got excited. It would have been cool if it was the same. It's not the same, so let's change that factoring. Because that's going to factor differently. That's going to factor to x minus 6 and x plus 1. Okay. Dang. All right, so now unique factors that show up in the denominators are x plus 1 and x minus 6. I'm going to distribute that to the 1 and to some of these other terms. And this is where I'll show you that some of you can kind of pick up on what's going to cancel, and that way you don't have to write out every single factor. So I know that when I distribute the x plus 1 and x minus 6, that x plus 1 is going to divide out with the x plus 1 I'm multiplying to it. So that's just 3 x minus 5 and then x minus 6 left over, because I know that x plus 1 is going to cancel out. So this is me just kind of doing some mental math as I work through this next step. The x plus 1 is going to cancel out with the x plus 1. This next factor, I get all the x minus 6 and x plus 1 to cancel out with what we distributed. So that just stays as x minus 3 and x minus 2. And then the 1, nothing cancels out with that. So that's just x plus 1, x minus 6. We've got a lot of multiplying to do here. So right now, if you're looking at this, you're like, wait, how in the heck did all those things divide out? You should not be skipping that step that I just did. And the step that I'm skipping is just writing out all these terms being distributed and then figuring out what cancels. I'm doing that all in one step. Okay, figuring out what cancels as I distribute. All right, so now on the left side here, let's do this. Let's distribute this 3 and call that 3x minus 15, x minus 6, and then it equals, this needs FOILed. X times x is x squared, then negative 2x, then negative 3x, then plus 6. This also needs FOILed. So plus x squared minus 6x plus x minus 6. On the left side, this now needs FOILed, so that's 3x squared minus 18x minus 15x. And then negative 15 times negative 6, that would be, I think, positive 90. And then on the right side, we're combining like terms, so x squareds together gives me 2x squared. Then I have a negative 2x, a negative 3x, a negative 6x, and a positive x. So that's negative 2 minus 3 is negative 5, minus 6 is negative 11, plus 1 is negative 10, so negative 10x. And then the 6 minus 6 cancels out. There's a lot of simplifying here. I am going to simplify the left side here, combining those x's. So that's 3x squared minus 33x plus 90 and equals 2x squared minus 10x. Okay, and let's just do this. Let's just get the right side to be 0, and then we'll figure out how we would solve that quadratic. We don't need to come up with the solution part. We'll call that good there, because it's the main thing that we're working on is getting to this point. Right? Once we get to this point and turn it into a quadratic, we should have a pretty good idea of how to solve that. So minus 2x squared, so that makes this 1x squared, add 10x, so that's minus 23x, and then we still have plus 90. Okay, so if we wanted to come up with the solutions, we're now deciding if that factors or if we have to do the quad formula. So are there two numbers that add to negative 23 and multiply to 90? I don't know, 15 and 6? 5 and 18? Yeah. Good. I said we're going to stop there, but we're basically done. X equals 5, x equals 18. And that comes from me setting each of those factors equal to 0. And then just cross-referencing them with any restrictions we have. Those restrictions being that x cannot equal 6 and x cannot equal negative 1.